Good evening all. You're welcome to the tutorials from Eternity the Schoolboy. Today we are going to take a look at physics, and the topic we have on the board is units and measurements. We'll continue from where we stopped. In our last lectures we talked about the derived and fundamental and derived quantity, and we talked about their various units, and we ended with derivation of the unit for the derived quantities, and that led us to dimensions of different physical quantities. So today we take a look at measurement proper. Our lectures on measurement will focus on measurement of length, area, and volume. We also talk about how to identify the units of length, area, and volume. And we'll take a look at the various equipment used in measuring length, area, and volume. And we also talk about how to determine the length, surface areas, and volume of both regular and irregular bodies. So let us go to measurements. Our lecture materials / reference book for today is New School Physics for Senior Secondary Schools by Professor M.W. Anyakoha, 2016 edition. So measurement is very, very important in physics. Even though measurement is very important, it can never be precise. It can never be precise. So because it can never be precise, we talk about the reading accuracy of the instrument you are doing using. So different instruments have their own reading accuracy. And because the number we got from measured number are approximate numbers, because they are approximate numbers, we say that we only take measurements that are specific to a particular number of significant figures, number of figures that are significant with respect to the measurement we want to take. You have a question? I ask, feel free.
What is precise?
Precise is that, okay, when when you measure a particular use a particular measuring instrument, let's say meter rule. Am I communicating? Now there is always room for error in that measurement. So okay, let me explain precise with a layman understanding. Before we come on to what I want to say now. If you say that something is precise, it's definite. It is this. Anywhere you go, anyhow you go about it, that is what it is. It is 20. Precise. It is 20. There is nothing like maybe room for error or room for okay, it's about this. It's something about so no. It's specific. It's discrete. Am I communicating? Discrete. That it is 20 or nothing. That is precise. It is 10. It's 10 or nothing. If you are counting a number, let's assume I have two stones here, about 10 stones here. It's 10. There's no other stone anywhere. The stone here, there are 10 numbers. The number there is discrete. It's precise. You can count it 1, 2, 3, 4, 10, up to 10. There are 10 stones. They're nothing like 10 points or, it's discrete, it's precise. That's what it is. I don't know if I'm communicating. But if you're measuring something, maybe with a meter rule, or you're weighing, there may be some errors. Maybe because of the measuring instrument you're using or how you measured it. It's not precise. Am I communicating? Now, when you measure, number we get from measurement that are known as approximate numbers. They are not absolute. You can say that those ones you measure from counting are absolute. This is what it is, absolute. You can say absolute, precise. But the one you take from measurement is approximate. Am I communicating? Yes. Good. So that's what it means by precise. Now let's continue. So I said that the measurement can never be perfectly precise. So what matters is this: you take into consideration the reading accuracy of the instrument you are doing you are using in measurements. Am I communicating? And after measurement, the only number you put down as your measured number is the number of significant figures that has to do with measurement you are doing taking. Am I communicating? Good. Now, so is my explanation clear? Okay, so now, because the measurements is not perfectly precise, as you are putting down the value you got, your measured value, you state the precision or the estimated uncertainty. But don't worry, by the time we enter different measures, different instruments, you understand what you mean by precision or the estimated uncertainty. But by the time we do that, you understand what it just hear it for hearing sake, okay? That's because the different because you measurements can never be perfectly precise. Whatever you are measuring, after measurement, you do take into consideration the precision of the instrument you are doing you are using for the measurements. Am I communicating? You call it precision or estimated uncertainty. Now, for example, let me give for example now. If you use metric rule, you know what a metric rule is. The one you call ruler. But the name is metric rule. Now, if you use a metric rule to measure, you find out that, have you ever seen something like this? Maybe after measurement, you are told that you have something like this, 20 plus or minus 0.1 cm. Have you seen anything like this before? Have you seen anything like this before? Now, this is what you measured, but you put this thing. This is the complete measurement you have done. This part plus or minus 0.1 cm. This is what you call the estimated uncertainty. Am I communicating? Estimated uncertainty. This part is called the estimated uncertainty. And do you know why it is called estimated uncertainty? I mentioned it before. I said that it is called estimated uncertainty because of precision. Estimated uncertainty of precision. Why it's called estimated uncertainty of precision is because measurement, the value you get from measurement and the value you get from counting are not the same thing. I think I mentioned it here. that counting value you get from counting is absolute. Like now, how many of you are here? You are what? Three students here. If I'm asking now, how many students are here? You people are three. It is absolute. It is precise. You are what? Three. There is no error anywhere. There is no instrument measure possible error in the instrument measuring. You are three. You are what? Three. It is what? Absolute. But if I want to measure your height now, I'll use either I use a rule that can measure up to your height, or tape, or use tape. That one, that's this is still rule anyway. They used to measure heights. Am I communicating? Calibrated in maybe mainly feet. Hello, it can be, you have it combined. Some part is feet, some part is cm, some part is what? Meter. Am I communicating? Good. Now, because of the possible error in that measurement, whatever number you get from such measurement is an what? Approximate what? Number. Is an what? Approximate what? Number. So numbers from measurement are what? Approximate what? Numbers. While numbers from counting are what? Absolute what? Number. Now, depending on the precision of the instrument used to measure such length or such quantity, that will determine the what should be here. Am I communicating? Am I communicating? Now, if you are using meter rule, you have 20. For example, now you want to measure the length of this book. The length of this book now. Maybe you measured it will give you around 20 centimeter, for example now. 20 centimeter. You must include this. This 0.1 came from the precision of the what? The meter rule you are using. But I don't want to go into that. When I go into different measurements, different instruments, I will talk about this. Each of these instruments have their own precision. Estimated uncertainty. Some can say accuracy. Am I communicating? But I'll talk about that when I go into each of these what? Instruments one after the other. Now, the significant figures you did in your secondary school, or you still do in your secondary school now, for those that are still in secondary school, has a lot of application in this measurement. Very important, because as I said before now, it is only the significant number. As I say, it is an approximate number. It's only the significant ones. It will be approximated to the significant figures. Number of significant figures with respect to the quantity you have in mind and the importance of what you are measuring and what you want to achieve by the measurement. And also the decimal places. Decimal place is also important here too. Decimal place is also important here too. Like now, something like if somebody comes to me and say that he used a meter rule to measure something, measure a length of something, maybe a book, and the person now what the person got is 20.56 centimeter. It's not possible. It is not possible. Do you know why it is not possible? It's not possible because you cannot. If you get the meter rule now, if you get the meter rule, the smallest. Is anybody here with meter rule? Thank you. Good. Let's take a good look at this meter rule. The smallest. This side, that one side is cm. Can you see it? One side is what? inch. Let's look at this side that is cm. This side that is cm, the smallest calibration you can get from here is what? From here to here, from 0 to 1 cm, right? Here is like, let me draw it on the board so you can see it. This is the meter rule. This is the meter rule. You have something like this, right? Here is what? 0. Here is what? 1. Here is what? 2. Here is what? 3. Now, in between this 1 and 0, you have what? Am I communicating? In between this 0 and 1, you have, here is 0.5, but they may not write it. And from 0 to 1 has 10 calibrations, 9 calibrations, making it 10 different what units. So you have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same thing with here. Do you know the implication of this? What it means is that from here to here, this is cm. From 0 to 1 is 1 cm. True or false? That means this place should be how many cm? 0.5 cm. That means this small one is what? 0.1 each. 0.1 cm each. Are we together? Now, the smallest this thing you can get here is what? 0.1 cm. 0.1 cm. 0.1 cm. Now, and somebody will now come and tell us that he used this. That means if the person is measuring, you have maybe, let's say from here to here is okay. Now I want to ask a question now before I can say what I want to say. I want to ask a question now. Let me complete the calibration. If someone now comes and tells you that I use this meter rule to measure 2.56, is it possible? 2.56. You know the person is lying, right? Yes. The person did not use the meter rule to measure the 2.56. Do you know why? The smaller calibration is 0.1. So how did the person do it? So the person has a microscopic eye that he was able to find out that if here is 1, let's assume that means here is what? 2, right? And here is 3. Here is 2.5. So the person is telling us that he has a microscopic eye to be able to measure it. If here is 2.5, that means here is 2 point what? 2.5. No, 2.5, 2.1, 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2 point what is here? 6. So that if this is 2.6, that means we have 2.5 cm, right? 2.5 cm. You have 2.6 cm. That means this 2.5 exists between 2.5 and 2.6. So the person had a microscopic eye and he was able to detect correctly 2.56. How possible is this? The person is not saying the what? The truth. He didn't use the what? The meter rule. So in cm, if someone said that he measured using a meter rule in cm, the decimal places the person must put the value is how many decimal places? 1 decimal place. It's not possible for someone to use meter rule that has calibration in cm, as I said now, and tell that he measured it with meter rule and got 2.56. It is not what? Possible. It's not what? Possible. Okay? Good. Now, this is what I mean by importance of what? The decimal places of the instrument you are, the importance of the decimal place in the measurements you are thinking of, you want to make. Remember, I said that this is when you are talking about what? In cm. But if it is in millimeter, is it possible? Even if it is in millimeter, is it possible? Huh? Is it possible? How is it possible? But you know it's possible. Now, how many millimeter make 1 centimeter? You say what? How many millimeter make? We did this in this class. So tell me. 10 millimeter make what? 1 what? Centimeter. 10 millimeter make one what? Centimeter. Now, with this at the back of our mind, let us now go straight to measurement of length. I've already described measurement of length, but I'll go a step deeper in the measurement of length. Now, measurement of length, of course, we have talked about what length is. That length is one of the fundamental unit, right? And we said that length can be measured. The SI unit for length is what? Meter, right? Meter, right? Even though it has other units. It has centimeter, it has millimeter, depending on what you want the instrument you are using. But the most important thing is that the SI unit, the agreed unit you should leave it at is what? Meter. Am I correct? That's the SI unit. Now, length can be measured using what? Depending on the length, the length you want to measure. In the science, in our normal physics lab, where we want to measure length, we use a meter rule. I think I have mentioned that one. We use what? Meter what? We use the meter what? Rule. Number 1. We use Callipers. Number 2. We use Callipers. We use vernier calipers. We use vernier calipers. We use micrometer screw gauge. Micrometer what? Screw gauge. So we use meter rule. We use calipers. We use vernier calipers. Then we use micrometer what? Screw gauge. Large, if you want to now start measuring large lengths in maybe distances, length, maybe plot of land, you start talking about tapes, right? Tape, right? Tapes and other instruments, but we are limiting ourselves to the one we use in our laboratory. Okay? Now, let's look at meter rule. The meter rule. I have mentioned here that the meter rule you are not writing anything. Why? Please, when lecture is going on, don't stay. Don't stay. Listen to a lecturer. Put down something, okay? Don't stay and be waiting for. I don't know what you're waiting for anyway. But don't just stay, because it will distract you. It will move your attention away from what we are talking about, okay? Now, I said that meter rule is calibrated or graduated in centimeters and what? Millimeters. I think I mentioned it here, right? Good. Now, I said here that the smallest, from what I described on the board here, what is the smallest graduation of a meter rule? 0.1 what? cm. Okay, what will it be in millimeter? What is it in millimeter? It can be 1. Meter rule is calibrated in what? Meter rule is calibrated in what? Good. Now, I now said First of all, length is, I listed the instrument use measuring length. See the I don't know what you are doing. I mentioned it here, I listed it here, but you are not. Do you listen to these lectures? Do you? Please, if you miss something in this class, listen to it and make up your note, okay? Please. Even if you are not able to put something, please go home, listen to it and make up your note, okay? As you listen to it, you be writing your note. If you pass a place, you pause it, then play it again, then use it to make up your notes. Your notes should not be scanty. If you miss the one in class, make sure that you do make it up at home. Okay? Please. Now let's continue. I said that meter rule is graduated in what? Centimeters and what? Centimeters and what? Millimeters. Are we together? Centimeters and what? Millimeters. If you look at this place now, there are some meter rule you see millimeter there, you also see what? Centimeter. And I ask a question here. I said, before now I ask you, how many millimeter make 1 centimeter? 10. 10 millimeter make 1 what? Centimeter. Good, I agree. 10 millimeter make 1 centimeter. And I now said that the minimum or smallest graduation of a meter rule, the minimum or smallest graduation of a meter rule is what? 0.1 what? Centimeter, right? I'm not asking you now, what is the value of 0.1 centimeter a millimeter? Centimeter a millimeter. You say it's 1 millimeter make 0.1 centimeter. What are you saying? 0.1. It's not. Oh yeah, do the calculation now also. 10 centimeter, 10 millimeter make 1 centimeter. So how many millimeter will make 0.1 centimeter? Also, what are you telling me here? You agree with me that 10 millimeter make what? 1 centimeter. You agree, right? And I ask you, and I say that the minimum graduation or the smallest graduation in the meter rule is what? 0.1 what? Centimeter. And I ask you, how many will it be in what? Millimeter? What do you get? 1. Is it true, Chibuzo? Is it true? All right, it's 1. So 1 what? Millimeter. 1 what? Millimeter. So what it means is this: that a meter rule is the smallest graduation in the meter rule is what? 0.1 centimeter or what? 1 millimeter. 0.1 centimeter or what? 1 millimeter. Now let's continue. So remember I told you about what did I say about here? Precision, right? And estimated what? Uncertainty. Now, I want you to differentiate between these two things. Please note these two things. I want to. They're not the same thing. We have what is called reading what? Accuracy, and we have what is called precision, or what? Estimated what? On what? certainty.
Now, the smallest graduation of a measuring instrument gives the what?
Precision.
Sorry, are we together? Please wait. Listen. Are you listening? Are you listening? Please listen, please. I said, just listen first before you write, so that if I make mistake, you correct it before you write. Just listen first. Understand what I'm saying, because sometimes the mouth will be saying something else. As the mouth is saying, if you don't reason before you write, you can start writing what. But as you listen, as I explain, you have a bigger picture of what I'm saying. Okay, just listen first, then understand before you write. Now, I said that there are two things that can be confusing at times, which I want you to listen carefully before you put it down. Now, I said we have what is called reading accuracy of any instrument. We have what is called reading what? Accuracy. Then we also have what is called precision or estimated what? Uncertainty. Hello? Precision or what? Estimated what? Uncertainty. Now, the reading accuracy of an instrument, reading accuracy of an instrument has a lot to do with the smallest graduation of that what? Instrument. Okay? Now, for a meter rule now, the smallest graduation of a meter rule is what? 0.1 cm or 1 millimeter. So the reading accuracy of a meter rule is what? 0.1 what? Centimeter. Okay? You can put that down. Now the reading accuracy of a measuring instrument is the what? The smallest what? Graduation of the what? Instrument. For example, now a meter rule. The reading accuracy of a meter rule is what? 0.1 what? Centimeter or 1 what? Millimeter. When you hear a meter rule, what comes to your mind? A meter rule means a ruler that you can measure up to what? 100 what? Centimeter, right? True of us? Because 100 centimeter makes 1 what? Meter. Is it true? Good. Now, then let's look at estimated uncertainty. Estimated uncertainty of an instrument is the half of its what? Half of its lowest its smallest what? Graduation. Half of its smallest what? Graduation gives you what? The estimated uncertainty of the meter of the measuring instrument. So that means if you are dealing with this meter rule now, what do you mean that the estimated uncertainty of the meter rule is what? From what I said now, half of what? 0.1. What does it define as estimated uncertainty now? Half of its what? So what is the estimated uncertainty of a meter rule? Centimeter is what? Half of 0.1 centimeter is what? What is it? 0.0 what? No, it's not. Do it now. Do it. What is it? Divide 0.01 by 2. What will it give you? Hey! Kakata emego ndị mmadụ ahụ n'obodo a biko. .05. 0.05 what? Centimeter or what? What millimeter?
0. What? 0. What? 0.5. It is either 0.05 centimeter or 0.5 millimeter. Please listen carefully. Listen carefully. Listen. Remember, I said before this class, I used 20.0.1 as an illustration to tell you what this means. This means error. Okay, error. Am I communicating? Error. This 0.1 means what? Error. Error permissible in using this what? In this what? Meter rule, okay? Is error. What it means is that if you have a measurement of, let me explain what this mean. Let me explain what this mean. Estimated uncertainty talks about what? Possible permissible error that can happen with that you can allow using that instrument. That is what he's talking about, because there must be an error. So there's the possible maximum you can do what? Allow. That's what this, anytime you see something like this, 20 plus or minus this, it talks about the maximum error, so that you can error that is permissible. The error. Now let me explain what this thing means. Let me explain what this thing means. Can I clean this? Let me explain what this thing means. For example, now, if we have something like this, if you have 21.55 plus or minus 0.05 what? Centimeter, or simply 21.5 plus or minus 0.5 millimeter. Look up, please look up. I want to explain something. Are you listening? Are you listening? What do I call this 0.05 centimeter? It's rated what? Which is an error, right? Error permissible, right? Good. Now, what do I call 0.1? For meter rule? Or what? What another name for it? Or what? Check your note now. What do I call it now? Reading accuracy. Okay? Reading what? Accuracy for a meter rule. Now, look at this now. Let me explain this. Do you know what this means? This is, you know, it's an estimate. You cannot measure it directly and get this. You can't measure it and get what? This. It's an estimate. Okay, this is okay. If the reading accuracy is 0.1, this is the accuracy of this meter rule. Okay, we can estimate half of it to be possible error that we can do what? We can estimate it up to what? 0.0, half of that is 0.1. Now, do you know what this means? What this means is that an error, you can measure instrument. The one you can have 2.55 centimeter
minus plus or minus plus 0.05. Add 0.05 to 2.55 and tell me what it will give you. Add 0.05 to 2.55. Tell me what it will give you. 2.6. You get what? 2.6 what? cm, right? Then subtract 0.05 from 2.55. Subtract 0.05 from 2.55. 2.5. What this means is this. Hope you can see the board. What this means is this. Let's assume that you want to measure a length 2.5. See what it means, that if you have if you get a value between 2.5 to what? 2.526. You can error between 2.5 to what? And if you measure and get anything that falls from 2.5 to 2.6, it is allowed. That's the meaning of this plus or minus what? 0.05. If you measure something and have it to fall from 2.5 to what? 2.6 is what? Allowed. Is what? Permissible. Does it make sense? Your face is telling me that it's not that clear. Huh? Are we together? Good. Now, I mentioned three things in this, and I mentioned its method of uncertainty. I mentioned reading accuracy. I mentioned the least or the minimum length, minimum calibration or graduation. All these things are important. Each of these instruments I'm going to call now have their minimum accuracy and their what? Its method of what? Uncertainty. Okay? Now, having understood this, have you heard of parallel error? Parallel error. What is parallel error? What is parallel error? Huh? What is parallax error? What does it mean? Chibuzo. What is parallax error? Do you know? Okay, now put it down. Parallax error. Then lax. Parallax. Parallax error. Now, what is parallax error? Now, before I define it, I want to explain it first so you can understand it. Now, look up. Look at this meter rule now. Look at this meter rule. Look at this meter rule. You want to use this meter rule to measure. Maybe you are here. You should come. Tofi should come. Come here, so you will understand this. Look at this. Here is, maybe you want to maybe a length for meter here. You want to check the length. Maybe we want to check if it's 10 cm. Instead of you to put your eye directly vertically on this line, you are looking at it from this side. If you stay here, I'm looking at it, you may think it's 9.9 or 9.8. True of us. Or if you look at it from this side, you may think it's what? 10.1 or 10.2. This error is called what? Parallax error. You should look at it straight on this point. Your eye should be straight on this, vertically on this point, before you can know where it's 10. Don't look from the side. You commit error due to what? Parallax. Now, what is parallax error? Understood? Now, what is parallax error? Bring it. Now, what is parallax error? Parallax error is the error committed in reading from a scale by wrongly placing the eye diagonally downwards on the point, or simply diagonally on the point of what? Measurement. On the point of measurement. On the point of what? Measurement. Are you there? When reading the scale. Error due to parallax. Error due to parallax can be avoided by placing the eye vertically downwards on the markings. By markings, I mean the point you want to take the measurement, okay? If it is at 10, you should place your eye vertically on 10 instead of diagonally or slightly. You know, when I say diagonally, you can use the word diagonal or use the word or slant, okay? Slant, okay? So error due to parallax. Remember this. Hello. I want to make a point, please. By the time we enter volume, this error, please parallax now. I'm defining is when using the meter rule. Hope you know. We are under what? Meter rule. When you go to measurement of volume, this thing will change. You know, measurement of volume now, you look at, you look what? The definition of this parallax error will change. Hope you know. Because there you're not talking about looking vertically. Because you are here, there you look what? Horizontally on the what? Marking. Hope you know. You don't look from the top. When it comes to what? Volume. Don't worry, when we go to volume, we'll define it better. But this thing I'm defining now is with respect to what? Using a meter rule, okay? Yes. Good. So maybe you can go to that place I define it. You can define how did I start? I say what? Okay, so you can put there parallax error. Okay, I said, call it again. What?
It is the error committed in reading from a scale by wrongly placing the eye diagonal. You say that diagonal we can put slant.
Yes. Slantly, yeah.
On the point of measurement when reading the scale. Then you said error due to parallax can be avoided by placing the eye vertically downward on the margin of what we want to take.
Okay, maybe you see what you do for you to understand. Because if I don't explain this now, you may think that is what you use in explaining that for what volume. It's not exactly the same way when we enter what volume. Because in volume you don't look from up. You look at the what. True of us, your eyes should be there. You don't look from below, or you look from the top. True of us. Those that have done titration should know that. You don't look from the below or upward. You look horizontally. You at the eye level. The level the marking or the point of reading should be at what? Eye level. So when you are defining error due to parallax now. Okay. Now with respect to length, now you can put the parallax error in using a meter rule, okay? In using a meter rule, so you understand what I'm talking about. In using a meter rule, so that you mistake it. But if you want to define parallax error generally, it's simply error committed while taking measurement by not placing our eye correctly on the marking, okay? Okay? Let's assume now you are asked. You are not there's no particular measuring instrument or quantity they have in mind for you to define, and they want you to define just parallax error on its own. You can simply say that is the error committed while doing what? Measuring, due to the fact that the eye is not well placed. True of us, is wrongly placed on the what? Scale. Simple. Because this one is what? General now. But when you're defining it with respect to meter rule now, you find out that, or measurement of length, you find out that you need to do what? In fact, are you also aware that if you understand this now, you can define this with any respect? Are you also aware that if you use meter rule now, maybe you have a meter rule for height now. Measuring length and height are not the same, hope you know. Now, you want to measure height. Maybe Chine, come and stand up here. Let me do experiments. Maybe you want to measure her height now. I want to explain this into you so that you understand that parallax error may not exactly it depends on the instrument you are using and what type of measurement you are making. Now, come here. Look at her now. Let's assume that you want to measure her height now. You see here. Have you seen that the definition of parallax error will change? Will it change? Will it change? It will change. It will change. Because here now, parallax error now will become error committed, where when your eye is maybe you check from the below, true or false, or from the top. Your eye should be at what? It should be at your what? Eye level. Horizontal, right? The same meter rule, the same metric rule, the same metric rule, the same tape. Let's say tape now in meters. The same tape. Talks about the same length too, but you are talking about what? Measuring from where? Horizontally, true or false? At your eye level, because you are standing at your eye level. Unless she's lying down. That's when you look vertically what? Downwards. True or false? So it depends on what you are measuring. That's why I don't want to call that the definition, the general one. You can sit down. So it depends on what you want to do, what? Measure. But do you understand what parallel error is? Once your eye is not well placed to get the correct measurement, to get the correct reading, it's a parallel what? Error. So you can define it in different situations. Maybe for volume, for length, for height, for width, for what have you. Depending on the direction of the measurements. Does it make sense? Does it make sense? Now, I've told you how to correct, how to avoid error due to what? Parallels. Now, apart from using a metric rule, I think I mentioned this. Apart from using a metric rule, you can measure large distances using other things like you can measure the length and width of a football field or land, right? A piece of land, true or false. You not use the meter rule now. You use what? Tapes, right? Steel tapes. You call it what? Steel tape. Who have seen steel tape before? Steel tape before. You use steel what? Tape. Where's my marker? You use steel what? Tape for large distances. Steel what? Tapes for large distances. Now, this is for measurement of what? Length, using meter rule. Let's go to what? Callipers. Let's go to what? Callipers. Let's go to calipers. So what do we use calipers to measure? We still use calipers to measure lengths. But what type of length do you use calipers to measure? We use calipers to measure the length of solid object. Solid object in cylindrical what? Form. Solid object in what? Cylindrical what? Form. We use calipers to measure length on solid objects in a cylindrical what? Form. When we say the length, specifically, let's assume now we have a cylindrical object. Let me draw a cylindrical object on the board now. Let me draw a cylindrical object on the board. If you have something like this, this is a what? Cylindrical what? Object. Now, this is a what? Cylindrical what? Object. Do you think what the calipers it looks like this? See how calipers look like. Calipers look like this. It has two jaws. Calipers has two jaws. Looks like this. There's sunlight screw here. Are we together? It has two jaws. These are the jaws of the what? Jaws. Jaws of the what? Caliper. It has 2 jaws. Now, this thing you want to measure is placed in between the what? Jaws, like this. So do you think is here we want to measure, or the diameter? Let me do you think what we are measuring is just the length as length, or whether we are measuring the diameter? If we put it in between this, I can now see what I mean. We have something like this. We have something like this. This is then the body, what you want to measure, you put it inside like this. What do you think we are measuring here? What do you think we are measuring here? Is what? Good. Is what? This thing should not come out here. This thing should be behind. Something like this. You can simply use a small meter rule to measure the length. This is it. You can call it the width or whatever you want to call it. You want to call it, but it's the what? The diameter you are doing what? Measuring. True or false? Now, if you get the caliper, it's simple. Just get maybe a small metallic object like bolt, small bolt. If you have you seen a boat before? A boat, you want to check the width of that boat. True or false? You put it then. Now take it, don't shift it, remove it from that boat. Maintain the length here you already measured. Then when you take it, clip it, you remove it gently and place it on a meter rule like this. You get a meter rule, place it and read the what? The length. Place it on a meter rule like this. Place it. Maybe so. Place it somewhere here. Maybe this is calibrated like this. 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. Like this. If you place it, maybe the distance from here, one jaw to the other jaw, maybe 2 centimeters. Okay? That means the length is what? 2 centimeters. Does it make sense? If you get it, this and place it, clip it, see, watch out. Is this in same deco? This is a same deco, right? You get the caliper, clip it here. Gently remove this thing. Don't shift, don't allow it to expand, to shift. You remove it and bring it and place on the what? Meter rule like this. And take the what? Measurements. This gives you the what? This length. True or false? True or false? Whether diameter, whether length as in height, whether what they are all what? Measure of what? Length. True or false? Now, but this one, if you clip it now, you know how many centimeters it is. Let's assume you check, you got 2 centimeters. That means the diameter is what? 2 centimeters. Does it make sense? Does it make sense? This is how to use what? Vernier caliper. So the length between the jaws is then measured. After clipping it, you touch the object in the correct position, as I showed you now. Then you place the jaws of the what is it called? Of the caliper on the meter rule. The length between the two jaws gives you the length you want to do what? Measure. Does it make sense? Good. So that is how to use what? Calipers. It's simple. It's not complicated. The one that is complicated is what? Vernier calipers and micrometer screw gauge. That one is somehow what? Those ones are somehow what? Are somehow complicated. Then that is where you should pay very, very close attention, because there are some calculations you will do if you want to use vernier calipers or micrometer what? Screw gauge. But after this, I'm going to give you assignment there. Now let's go. Let's look at vernier calipers. Let's look at what? Vernier what? Calipers. Let's look at the what? Vernier calipers. Are we together? Good. Now we use vernier calipers to measure small lengths. Small what? Lengths. Small lengths that you cannot easily measure with a meter rule, okay? There are small lengths you cannot easily measure. In fact, if you measure with meter rule, you have errors. It's very small lengths. So that means vernier calipers is more accurate than what? Meter rule. True of us in measuring small length. True of us is more accurate than what? It measures small length more accurately than what? Than a meter what? Rule. So what type of length can you measure with what? What type of length can you measure with what? Vernier calipers. You can measure length like thickness of a meter rule. Look at this meter rule now. Can you use meter rule to measure this thickness? Thickness of this meter rule. You can measure it using what? Vernier what? Calipers. Now, your test tube you use in the class, in your chemistry lab. Hello? The test tube you use in your chemistry lab. That test tube you use in your chemistry lab. Are you aware that the thickness, or simply the diameters, both the internal and external diameters are measurable. Let me. Do you know what I mean by internal and external diameter? Now let me draw something to explain what I mean by internal and external what? The diameters. This is your test tube. This is your test tube, right? Your test tube is like this, right? True of us? Good. Now let me turn it like this. If I turn it like this and just look at the opening. If I turn it like this, I hear that it looks like this. True of us? True of us? True of us? If you turn like this and look inside, this is how the opening look like, right? It has double this. True of us? Because it has thickness, right? Good. Now look at this thing now. You can use anything, not only but I use test tube because it's small. Now let's look at this now. Internal diameter is this. Inside, right? This is the what? Internal what? Diameter of this what? Test tube. External diameter is this one. From here to what? Here is what? External what? Diameter. Capital D. Internal small d. Are we together? Eh? Is it clear? The entire diameter is from here to what? Inside diameter. That inside layer, the diameter of that inside layer. If you hear diameter, you know what the diameter is, right? Good. Inside layer, the diameter of the inside layer is the what? External what? Internal what? Diameter. While the external diameter is from this outer layer to this outer layer is what? External. From one end of this outer layer to the one end is what? External. Actually, sit up. Is what? External what? Diameter. Is it clear? Is it clear? Now, with vernier caliper, you can measure both the what? Internal and the what? External diameter of this tube. So you can use vernier caliper for thickness of a what? Meter rule, internal and external diameters of what? Of a tube. You can also use it to measure the diameter of a rod. Maybe the rod may be smaller than this one. This cylindrical object we wrote here. Maybe the rod may be smaller than this cylindrical object we wrote here. You use what? Vernier caliper to do what? Measure such length. You use vernier caliper to measure such length. Now let's continue. Another thing I want us to look at is what? How does a vernier caliper look like? How does a vernier caliper look like? I'll draw a schematic diagram now, explaining how it looks like. But before I will do that, I want to do one or two explanations. Let's talk about something. Let's talk about the reading accuracy of vernier caliper. Reading accuracy of vernier caliper is 0.01 cm. Put it down, it's very important. Very, very important. Reading accuracy of vernier caliper is what? 0.01 cm, or how many millimeter? 0.01 cm or how many millimeter? 1 cm or how many millimeter? How many millimeter? 0.1 what? Millimeter. Good. So reading accuracy of a vernier caliper is 0.01 cm or 0.1 what? Millimeter. Please note it. Note it. Now let me draw a vernier caliper. I need a schematic diagram that will drive home the point I want to make. That will have all the ingredients without confusing you. Now, as you can see on the board, what you have on the board is what? Vernier caliper. Okay? Vernier what? Calipers. I will explain what happened in vernier calipers. I have already told you about the reading accuracy. What is the reading accuracy of vernier calipers? 0.0 what? 1 cm or what? 0.1 what? Millimeter. That's the reading accuracy of what? Vernier caliper. Now, as you can see, vernier caliper has two scales. These things that you are seeing, this calibrated area are called what? Scales. It has two scales. The main scale and the what? Vernier scale. Main scale and what? Vernier scale. Put it down. Vernier calipers has two scales. The main scales and the what? Vernier scale. Okay? The main scale and the what? The vernier scale. Doing measurements, the main scale as you can, doing measurements, the vernier scale slides on the what? Main scale. Look up. There is a screw here. We call it lock screw. If you open the screw now, you can move. Look up. Just look up. Let me explain something. Let me. If you look at this thing now, if this thing here is not, this is a cylinder. So unlike the tube, this tube you are talking about, this tube, your test tube now, even though your test tube may break, but you should be careful so that as you put it, it will not break. Let's say maybe rubber tube or plastic tube or something that cannot break easily. Look up. If you open the screw, you slide this thing, this here, from here to here is the what? Vernier what? Scale. You can move it along the what? Main what? Scale. If you lose this nut, this screw, you can move it up to this place. Now let's assume this thing you are seeing here now is a mouth of a cylindrical tube. Now you want to check the external diameter. This side checks the external diameter. This side, the one that enter inside like this, check the what? Internal diameter. Now if you want to check the external diameter of any cylinder, any cylindrical object, that any tube, sorry, this is where you put it. Now if you did not put this tube here now, this thing would have closed up. But if you want to put a tube here now, you lose the thing, put it so that you adjust it to fit in to the size of the what? The tube, the external diameter of this. When you fix it and want the thing cannot fall off, if you can hold it and the thing cannot fall off, the thing has fitting into the jaws. These are the jaws of the what? Main of the caliper. Now, as you put it now, you need to shift it back before it can enter. Hope you know. Now, you can now take the reading on this thing. Whatever reading you get here is the external diameter of this tube. The same way, if you want to check the internal one, you turn it upside down and fix it inside this. Let's assume if you open this now, you want to check the inside the internal diameter. You put it. If this is closed like this, this place will be together. You open it and lose it so that it can open and hook on the what? Internal surface. Am I communicating? Now, if it hooks and does not fall off, you have put it has fitting into the internal diameter. You simply take the what? Reading. Did you understand what I said now? Now, this is how to put it before you take a measurement. How do you now take your what? Measurements. Now, I told you that it has what? Two scales. The main scale and the what? Vernier scale. Now, the main scale is calibrated in centimeter. Hello? Two of them can be in centimeter. They both can be in what? Millimeter. But we are working on what? Centimeter. After we can convert to what? Millimeter. Okay? Now, if you look at the main scale now, see, this is 0 cm, right? Here is 1 cm. Here is what? 2 cm. We are still on the main scale. 3 cm, 4 cm, 5 cm. This breakage means that it's continuous. Stay when? 9 cm and end in what? 10 cm. Now, this is the main scale. The vernier scale is this one here. Here is what? This scale here is what? Vernier what? Scale. Now, each main scale, let's assume this is the main scale now. 1, 2, 3, 4, 5. This is 0, right? Here is 0. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the main scale. Look up, look up, look up. This is the main scale. Main scale has 10 divisions, right? 1 cm, 1.1, 0 cm, sorry, 0.1, 0.2, 0.3, 0.4, 0.5, right? 0.6, 0.7, 0.8, 0.9, 1 cm. Is it clear? 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8. Are you looking up? 1.9. What should be here? 2 cm. 2.1, 2.2, 2.3, 2.4, etc. This is the what? Main scale. But vernier scale, each, see where the vernier scale now, the relationship between vernier scale and the main scale. From here to here is 1 cm, right? In the main scale. Look at, as you can see here now, from here to here is what? 1 cm. Now, for vernier scale, for main scale, this subdivision is what? 0.1 what? Cm, right? But for main scale, a subdivision, a calibration is what? 0.1. But for the vernier scale, a calibration is what? 0.01. Okay? Note these two things. For main scale, a calibration is what? 0.1 cm. But for the vernier scale, a calibration there is what? Represent what? 0.01 cm. Note that point. That means if you have 1 cm in vernier scale, that means if you have 0.1 cm in vernier scale, that means divided by 10, right? Right? You have what? 0.01 cm in the what? Vernier scale. Now, this is the first point I want you to note. Now, do you know how to take these measurements? You add up the measurement you get in the what? Main scale, and the measurement you get in the what? Vernier scale, and add them together. It will give you the measurement of this, either internal diameter or the what? External what? Either the external diameter of the what? Internal what? Diameter. Now, look up. Let's assume, please, so these two things doesn't mean that you can't measure them at the same time. Hope you know. You measure one first, okay? Let's assume that what we want to measure first is the what? External diameter. Let's assume that what we want to measure first is what? External diameter. Look up, and you put this thing here, loosen the lock screw, and shift this vernier scale to fit in. Once it fits in, you lock up. It will not do what? Fall off. You look at this place. Here is what? 0. Start from the main scale first. Here is what? 0, right? Here is what? Here is 0. Here is what? 0.5. Check where now. This is 1 now. Here is 0. Here is what? 0.5. Okay, let me count it one by one. Here is 0, right? Here is 0.1. Or you count with me. 0.1, 0.2, 0.3, 0.4, 0.5, right? 0.6, 0.7, 0.8, 0.9, 1. This is 1. 1.1, 1.2. 1.2. There are others behind this thing, okay? Here, behind this thing, you have 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. Before you still see what? 2. Now look up. You are still counting on the what? Main scale, right? 2 point is here. 2.1, 2.2, 2.3, 2.4, 2.5. Now, where do you now know when the vernier scale will come in? We have entered here, right? Hope you know. Vernier scale started from here, but where will you know when to stop counting on the main scale and now count the vernier scale. At any point where the main scale and the vernier scale coincide, you know what I mean by coinciding? They align. That is where you stop counting the what? Look up. Look up. Before the calibration, before the point where the main scale coincide with the what? Vernier scale. That's where you stop. Before that point of coinciding point, that's where you stop. Then you count the what? Vernier scale and add up. Look up. If I want to measure this now, I have 2 here, right? Where do you think the main scale and vernier scale coincide here? 2 point what? Come closer. 3 of you, come closer. Come closer. Come and look at this thing very well. Tell me exactly where they coincide. Come and identify it. Let me know whether you are following me. Go to the board, identify, look at it critically and identify it. Go there.
You see, both of them are right. Like, okay, I've been aligned. Me, if I never could be doing this.
Chalo, sorry. See what I mean? I mean to say, immediately, sorry, come close. I made a mistake. See what I mean here. Let me not confuse you. Sorry, initially I said that you stop counting the main scale where they coincide. That's wrong. See what you do. Immediately, you want to, the nearest, before you start seeing the vernier scale, the nearest calibration of the calibration of the main scale that is immediately before you start counting, seeing that of what? The vernier scale. That's where you stop counting the what? Main scale. Now look at this place. Where do you think we can stop counting the main scale? 2 point what? 2 point what? 2.1. True of us. This after this 2.1, you start seeing the what? Vernier scale. So you read that one as the main scale, the reading on the main scale. Now, how do you now know where you start counting the reading from the what? Vernier scale. You look for where the vernier scale coincide with the what? Main scale. Where?
It's 2.1.
I mean coincide. Where they overlap. See it here.
So how do they kick us?
Look at it now. This one, remember I said that this one on top is the what? Main scale. This one below is the what? Vernier scale. But I tell you, but I put it. I didn't say it here. I said that this thing here I see the main scale. Oh. This one below is what? Vernier scale. This is the vernier. Now look at it now. From where they consigned, that's where you started it. Remember, I told you that for vernier scale is 0.01. Remember. So if one division is vernier scale is 0.01, here is what? 0. What? No, now first one is what? 0.01. Are you following? 0.02, 0.0. So here should be 0.05 from the vernier scale. So if you want to take the total, if you want to check everything now, it becomes what? 2.1 plus 0. What? 2.1 plus what? 0.05. It will give you what? 2.1 plus 0.05. It will give you what? 15 cm. Is it clear?
So every main scale is 2.1.
Every main
scale is always 2.1.
No. This is what you measured here. It depends on what you are measuring. You shifted this thing before it moved. For this measurement now, for this thing you measure now, that what means that the external diameter of this now is what? 2.15 cm. Yeah.
Make it for me and
Nibu, how?
it's a mom. It's not concerned. If you
See, you are in Nigeria. No one will speak anything for you in Igbo. Try to understand, please. On most serious note, that is not a. You can't do anything about it. We have not started learning in Igbo language.
Okay, like 0.0.
5. So, Kimi by Eba concile, like, or the faith.
Don't know what is coinciding. Coincide. Want to go, get your phone. Check the meaning of coinciding. Also go there. Coincide. When two points coincide, when they align, overlap, touch each other, check it, coincide. Fast. Never coincide, check it. Huh? If we're getting. Okay. So where the coincide, what does it mean? Open it well now. Fall down or together. Fall down. No. Koi.
Oh, fine.
Chinanya.
Okay, I'll catch.
Check it now. What is it? What did they say?
No,
Occur, good, coincide. Look at it now. I'm not saying you can sit down. Come here. Coincide. I say where the vernier scale and the main scale and vernier scale coincide. First thing to note is this: main scale stops at the calibration before the beginning of the what? Vernier scale. Vernier scale calibration. Look at it. You know this thing can also be here. This the vernier scale can be shifted here. That's why you have screw here. You can shift it like this. Depending on the distance, the length you're measuring. If this thing is bigger now, that means this thing may be here. That's why you have screw. You move it like this. Okay? Now, when the smallest unit now, this is the main scale, right? We have 2 and 2.1, right? Now, if you immediately after this 2.1, you start the vernier scale calibration will start. True of us. Now, this is where the main scale will stop, 2.1 cm. Now, what is the vernier scale now? You look for where the vernier scale coincide. You start counting from here, but you stop where it coincide with the what? Main scale. It coincides with the main scale here, so you stop here, but you start counting here. But remember, one calibration in vernier scale is what? 0.01 cm. So this is 0.01, 0.02, 0.03, 0.04, 0.05. Look at it here. You add two of them, you get what? 2.15 cm. So the external diameter of this tube now is what? 2.15 cm. Does it make sense? Yeah. This is how to use what? Vernier what? Caliper. This is how to use what? Vernier what? Caliper. Maybe by the time we solve one or two questions, you will appreciate that, okay? So I will conclude with, I want to just, did I mention the reading accuracy of vernier caliper? You say no now. No. What is going on here? Now, okay, now this thing now in millimeter is what? This 2.15 cm in millimeter is what? 15 cm. Move it to millimeter. Is what now in millimeter? 21.5, right? Millimeter. Is it clear? Is it clear? Good. Okay. Now let's continue. Let me. There's a precaution you need to take while using this vernier caliper. Please look up. Oh. There's a precaution you need to take while using vernier caliper. Look up. While using vernier caliper, you take this precaution. The precaution is this. You know that if there's nothing here, this thing will come here. Hope you know. Are you aware? This thing will tight here. We lap here. And if this thing lap here, what it means that everything here should be zeroed. Vernier caliper, main scale should be what? 0. Vernier scale should be what? 0. All of them should be what? At 0. Hello? Before you start using the vernier caliper, make sure. Are you listening to me? You know that there's nothing inside it. So it should overlap. The two jaws should be together. That means the scale should be at what? 0. Both the main and the vernier scale. Note that one. But let's assume that you now want to use a vernier caliper and you look at it and there is nothing, the two jaws are together. But you are looking at it's not at 0. The scale is not at what? At what? 0. Do you know what you would do? And you try to zero it or what? Look at it. Look at, maybe you are seeing that it's at 1 cm. Maybe you notice that it's at 1 cm. For example now, or maybe it's at 1 cm is too much. Are you listening to me? Maybe you notice that the thing is at 0.1 cm on the main scale. Am I communicating? Then maybe the same thing with maybe for the what is it called? For the vernier scale is at where? 0.01 cm. Do you know what you do? Let's assume that this length is what you want to measure. This is the external diameter. But it's not at 0. Do you know what you will do? Note where the thing is. Then take your measurement after you subtract what was here. Okay? You subtract what was here from what you got. You get the accurate what? Let's assume that it's not at 0 before you start measurements. Then you got here 2.1. That means the accurate measurement is actually what? 2. True of us. You subtract this place from it, okay? Haven't you measured something in your school before? It's what you are writing now. Come to the front. Come here. Come. I didn't say you can write, but try to understand something before you write. Come and sit down here. This thing you are saying that you are doing it in your note now, but you don't understand what you wrote. True of us. Okay? True of us. I was talking, you are writing, but you do understand what you are writing. That's why after writing you become confused. Please, when the lecture is going on, try to understand before you write. Okay? Now look up. I said, let's assume. I'm teaching you how to use it practically to avoid error. There's what is called zeroing of an instrument. When there's nothing in these two jaws, you know where the jaws are, right? These are the jaws. You can label it jaws. These are the what? Jaws. The two jaws here. When there is nothing inside this jaw, remember it's because of this thing you put here that this thing shifted. Hope you know. If there is nothing inside this jaw here, this thing will be here at what? 0. True of us. But maybe because the instrument has started developing problem or whatever reason is possible, whatever reason, you notice that there is nothing here, but this thing is not at 0. Maybe it's at what? 0.1. Maybe it's somewhere here. Instead of being here at 0, it's where? It's stopped here. What are you going to do? Am I communicating? It's at what? 0. The same thing with this one. Instead of being at 0, it's at 0.01. What will you do? See what you will do. You know that it's at 0.1, but just take your measurement because you try to bring it to 0. You couldn't. Just take a measurement. At the end of your measurement, you subtract that initial reading you got. It was in when there's nothing there. Subtract it from the final value you got. That will give you the actual what? Value. Is it clear now? Subtract the final reading you got now. Okay. Let me explain something now. Okay, a weighing balance now. Maybe I think let me, even though we have not discussed weight, but have you ever used a weighing balance scale in your daddy's pharmacy? It's not there. Have you ever jumped on it before? Now, it's expected that if you are not on the scale, on the weighing scale, if nothing is there, that thing that moves like this, that's we call it what? Spindle that moves on the scale when you climb that weighing scale, is expected to be at where? 0 now. Is expected to be at where? 0. But sometimes you will look at it, nothing is there. It will be at 0.1 kilogram. It's possible sometimes. And you do everything possible for it to be at 0. It will not be at 0. What will you do? If you climb on it like that and get that your weight is and get 51 kg. Is 51 kg your weight? What will be your weight? The correct weight. Use your sense now to do this. What will be your main weight? Something that's supposed to be at 0 before you climb is at 0.1 kg. And you use it to measure your weight. Your weight is now 51 kg. What is your actual weight? You are putting a calculator. Huh? 50, okay. Let's say it's at 1 kg. It's not 50. Let's say it's at 1 kg. Let me say 1 kg, okay? Instead of 0. Let's say it's at 1 kg. Instead of 0. And you climbed and got 51. Do you think that 51 kg you got is your real weight? What's your real weight? What I'm trying to explain here is now that if there is nothing here, it's expected that this thing should be at what? 0. But if it's at a particular any other point that is not 0, if you use it to measure, at the end subtract the initial place it was. But if not, you get a wrong reading. That is the possible error you can get in using. It's like that in most of the instruments. We call it zeroing of what? The instrument. You zero it, be sure that it's a 0. But if you cannot, this is what you will do. It's also called what? Zeroing. So once you subtract the initial where it was before, from where the final thing you got the actual measurement you took. Both of them. Huh? Yes, you can. You can. Just check it. 2 of them must be at 0. 2 of them must be where? At 0. Okay? Now look up again. Look up again. If there is nothing here now, you shift this thing like this. Do you believe that? Are you aware that everything here, this is 0 for what? Linear scale, right? Yeah. You should align it here. This is 0. Are we together? You should do what? Align with what? This is 0. You should what? Align with what? 0. But if at M you have 2.15. Now, and whatever it was before you started, maybe you notice that it was at 0.1. Subtract everything from here. Subtract from here 2.1. If you have 0.1, what should it be in the linear scale? 0.1. You have what? 0. This, right? Now, if you subtract 0.01, we have 0.04, right? Right? You subtract 1 from here, 0.1 here, you have what? 2. 2 plus 0.04. 2 plus 0.04, you have 2 point what? 2 point what? 2.04. Right? Then add these two. Then subtract 2.15, subtract 0.11. You have what? 2.04. Does that make sense? There we go. What's going on here? Huh? Okay. It's okay. Just check where any error, any shift that is not at 0. Subtract it from the final value. Okay? Are you okay with it? Once it doesn't rhyme, once it doesn't align with 0, whatever difference, whatever you notice that is deviation from 0, you notice. So to subtract it from the final what? Reading. Is it okay? Is it okay? Let's stop here before I confuse them. Don't worry, by the time we keep solving question, I pray we'll have question in this form. You will understand it better. Okay? Now, let me solve one question. Then I'll give assignment. We'll call it a day. We'll close for today. Take down this question. Please draw the diagram. The diagram here is vernier what? Is vernier what? Caliper. The question says, what is the reading? What is the reading of the vernier caliper shown below? What is the reading of the vernier caliper shown below? These are the options. Option A is 1.79 cm, B 1.73 cm, C 1.39 cm, D 1.34 cm. I'll give you 1 minute to try this question. Try it. Don't be scared. Try it. 1 minute. Fast. You got what?
1.39 cm.
Chinaya got 1 point what?
39
1.39. What are you saying? You see 1.39. You're looking at 1.39. Isn't it like 1.39? 1.39. Did I say it in the class today? And you're calling 1.39 here. But stop it. It's wrong. It's 1.3. So you what do you get? Come see. Huh? Let me see what you're solving. Come. You know, what have you been doing since? Oh yeah, say it now. Say what you've been doing. But I asked you to solve it. Why not solving? You don't know what you will solve. Okay, but what I tell about this thing? Repeat what I said about in this thing. Which one is the main scale and which one is the vernier scale? Vernier scale is what? Now, what did I say about calibration of the main scale? This is how is this calibrated now?
0.1.
What is here? Huh?
1 cm.
So here should be what?
1 cm.
Ever beginning?
1 cm.
Ever beginning?
2 cm.
Huh?
2 cm.
Not to see me by now.
Okay. 0.5.
Ever beginning?
1 cm.
Ever beginning?
1.5.
1 point what?
1.1.
Continue.
1.2. 1.3. 1.5. So we now start from the
Continue.
0.01, 0.02, 0.03, 0.04.
So where are they concerned? Go there and read it. Get up. Go there and read what we are because essay husband about you in essay husband ever. If it's not clear, why not go close and see it well? Or yeah, tell me the answer from that board now. See, don't switch off in class, it's wrong. Listen to me. Don't switch off in class, it's wrong. Believe in yourself. When something has been taught to you and you are given something to solve, don't switch off. Try it, keep solving it, don't give up. I don't know it. Oh yeah, for nothing on the board, tell me the answer. Also, start from the beginning. First of all, you should study the scaling. Hello? First of all, listen carefully. It's not a look up. Oh. It's not compulsory that this must be 1.1. Look at the scaling. What if you see 2 cm here and go? What will not be here? If this place is not here, if this 2 cm is here, 4 cm, here is what? 2 cm is here. 1 cm. Count one there. 1, 2, 3, 4, 5. Divide the iron by different. 2 minus 1 is what? 1. Divided by 5 calibration. It will give you what? 1 divided by 5 is what? By 5 is what? 0.2. So that means each of these is what? 0.2. Do you know why each of this is 0.1? I'm asking you, come see. Because 2 minus 1 is what? 1. Divided by 10 calibration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will give you what? 1 divided by 10 is what? Calculate go now low. Keep that calculator. Keep it. It's okay. Don't use calculator again in my class. Keep it. 0. Don't ever try to calculate again in my class. I won't take it again. Sit up, you. 0. What? Have you seen why here is what? 0.1. First of all, take the 2 ends, subtract them. Here for the divided by the calibration, you get what? 0.1. Is it clear? So that's where here is 0.1. But had it been here is 2. Here becomes what? 1, right? 1 point what? If 2 is here becomes 1 point what? If 2 cm is here, what is the calibration now? Wait, finish it first. Let them do it. 0. So here is what? 1. 1.
0.
How can it be 1 and 0.2? 1 here should be what? Add it to this one now. Here is what? This is what?
0.
Here is 1. Here should be 1.2 now.
Okay.
What's okay? What is the problem, can see? Here is 1. Here is 1.2. Here is what? 1.3.
1.2
plus 0.2. Onye again? 1.4. Here is what?
1.6. 1.8.
If we are now, it's 2. But we have here to here. So this calibration is what? 0.1. So let's start counting. Be answering. Come see. Louder. 1 point. You stop here. Why? Because Venus scale has started here. Here, that means on the vernier scale you have what? 1.3. On vernier scale you have what? 1.3 what? cm. Let's check the. Sorry, I mean on the main scale. Thank you. On the main scale you have what? 1.3. Let's check that of the. Are you following us? Don't say yes when you're not following, because I'll still call you here. 1.3, right? In the main scale. Now let's look for the vernier scale. Where the what is the at what point do we have do you notice that the main scale and the vernier scale coincide? Touch it. So here, good. Remember, do you know why here is 0.0001? Because we divided the main scale by what? 10. Remember, 0.1 divided by 10 is what? 0.01. Had it been here is 0.2, you divide it by 10, here will become what? 0.02. Please note those points, okay? So here is what? 0 on the vernier scale. Here is what? Louder.
0.2. 0.3. 0.4.
Or 0 points. You don't see? 0.
0.1.
On the vernier scale, what are you saying?
Sorry. 0.01.
0.01.
0.02. 0.03. 0.04. 0.05. 0.06. 0.07. 0.08.
0.09. So we have 0.09 cm on the what? Vernier scale. So vernier scale is what? Plus what? 0.09 cm. So add 0.3 to 0.09 cm, you get what? Align your decimal. Double everything. You bring a calculator. Learn how to do these things without calculator. You have what? Align your decimal 1.3, right? Plus what? Decimal point should be here, right? 0 should be here. This 0 will be here. And what? 9. Add up. There's nothing here, so here should be what? 9. This is what? 3. This is what? This is what? 1. So the answer is what? 1.39 what? cm. 1.39 what? cm. Sure. 1.39 what? Can you say again now? 1.39 what? cm. So the answer is what? C, right? C. 1.39 what? cm. So this is how to measure with what? Vernier what? Calipers. Even if you are asked to measure internal diameter, you just place it here. Look up. Just turn it upside down and fix it here. You measure it. Okay? All right. So at this point, I want to give assignment. We'll review tomorrow. Yeah, I said I will not review assignment again. No more 1 week. As they hot, as you go home now, do the assignment. As they hot. Tomorrow we'll review it. Before we do our lecture for tomorrow. Let me get question. How? Come quick. Let me answer your question. How do I know? 10 cm. Hey, look at it now. If the first thing you look at is there, look up. Oh, she asked question. How do I know that? Again.
10 calibration.
Look at now. How do you know that it's you look at the question you are given. From here to here is 1 cm, 2 cm. You count it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, ever say this is what 0. Even though they so that they know that anything. Did they write anything here for you? You should know that here is what 0, 1, 2. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 calibrations. Then 2 minus 1 is what 1 divided by 10. So ofurimi here was 0.1 cm. Man nke bụ gịnị 0.0. Nke a bụ 10 division of ofunka. One division of vernier scale is 10 division of what? one division of what? One division of vernal scale is equivalent to 10 division of one of what? Main scale. Okay, so if here is 0.1, here is what? 0.01. Just divide this one by 10. You have 0.01. That is how. So any reading you got, any calculation you get from this thing divided by 10, you get that of the what? Vernal scale. Have I answered your question? I gave assignment. You didn't bother to. I gave you something to solve. You didn't bother to try. You just did this thought and give up. Don't give up. That is not the spirit of learning. The spirit of learning is that you keep struggling, no matter what it is. Don't give up. That without it you cannot learn. You don't give up. Even if you are failing it, do it. Keep doing it. Don't say I don't know it. Then they are not like I don't know it. Keep trying. Keep solving it because you were here. I explained it. Go through your notes. See how you can do this thing. That is the spirit of learning. Okay? All right. Okay, put down this assignment. I want to give 2 assignments. Just put it down. Put it down. Are we together? Are we together? Number one. Which of the following units? Sorry. Wait. Sorry, please. Wait. I made a mistake. Listen, please. Which of the units of the following physical quantities? Which of the units of the following physical quantities are derived? Which of the units of the following physical quantities are derived? Which of the units of the following physical quantities are derived? This is type of question they will list I. Then after you start seeing option A, I. Have you seen such question before? Good. So please note that. So, all right, let's go. Area. Thrust as in THRUST, thrust. Thrust. Pressure. IV, mass. Then option A. I and IV. Option B. I and I only. Option C. I and IV only. Option D. I and I only. Option E. I and IV only. I and IV only. Then question number 2. The diagram below represents a portion of a vernier caliper. The diagram below represents a portion of a vernier caliper, full stop. What is its reading? What is its reading? What is its reading? ITS. What is its reading? Option A. 7.10 cm. 7.10 cm. Option B. 7.09 cm. 7.09 cm. Option C. 6.90 cm. 6.90 cm. Option D. 6.34 cm. 6.34 cm. Option E. 6.29 cm. 6.29 cm. All right, on the board is the vernier caliper, the portion of the vernier caliper. So if you don't see it clearly, come closer. Let me put this touch. It's already dark. Look at it. Look at it very well. Draw it the way it is. Just draw this in the way it. Just follow exactly the way it is there. Follow exactly what you are seeing there. Okay? Just draw exactly the way it is there. Draw exactly what you are seeing there. I don't know. Any question? Any question?
So this thing that I counted, this thing I counted here now, is it this thing?
Is it what?
This one I counted here and it's 10. Is it this thing? Is it this one or this one I counted?
Everything there. All of them.
I'm not saying I counted this one. This one I counted there, is it this calibration or is it the C and the B?
Come see. I have solved this type of question before. Even before I explain it here. That's why it's an assignment. Go home, sit down. See. In calibration, everything here is calibration. Count everything here. Forget they are all calibration. They can put it in any form they want to put it. You are only to do what? Know the readings. Know the scale you are given and count based on the scale you are given. Are you with me? So don't be confused with this small one, big one. Just follow exactly the scale you are given and count it. Since you know that the only two figures you are seeing here are 6 and 7, it's true of us. Then count on what is between them now. 7 minus 6 is what? Yeah, count on what is between them. Know what this small one will give you. Simple. I just know. Go and do your assignments. Go and do your assignments. Sit down. That's what it's assignment. Sit down, crack your brain and first Chibuzo. Chibu, tell me here. Sit down. That's why it's an assignment. If I give you assignment and sorry for you, then I don't know. I'm not helping you. You can't be asking me questions in assignment I gave you in class. It's wrong.
I'm not asking you.
It is this assignment now, right?
But this one now that is 2 minus 1, and then divided by that 10, and give 0.1. If you want to add it, like if you want to do the second calculation now, I think you add it to that one that is subtracted. Like that 0.1 plus 1 is subtracted from there.
I don't understand. Let me understand what you're saying.
Wait.
Wait.
Here you did 2 minus 1. And it gives you 1. I now divided it by this pen here,
Uh-huh.
and it gave me 0.1. Here is not 0.1.
Here is 1 now. Here should add it to this one now. What are you even saying? Come see. Yeah. Come. What happened to you today? What you look so distracted today. What is no, come. I know what I'm saying. Come. What is the problem?
I'm not distracted.
You are. If you go question up to how many times this evening? Impossible. You're not asking the same question again. That means something is not somewhere. True of us. No. See. Then if something has been explained to you, we're talking, it's okay. You can sit down. You can take us but that means something is wrong somewhere. But I don't know what is trying to, but you don't want to say it. Please, I beg you, concentrate, please. Oh, because I don't know what it is, but just concentrate. When my student is losing concentration, I know. Whenever my student is losing concentration, I know. So please, put yourself together. Animaro. Okay, do you know the reason? You were talking that talking can make you lose concentration. True of us. But I knew. I don't know the source, but I knew you were not concentrating. That was why I was saying it, because I knew you were losing concentration. A good teacher should be able to know when his student is losing concentration. If each of your students, you should be able to say this person is losing concentration. No matter how the person hide, you will know. But some may be an issue at home. Some may be they are thinking about one nonsense. Some may be different things, but the point is that this person is losing concentration. That's the point. I don't want to confess now that they're discussing. Are you supposed to be discussing in class? It's all the very wrong now. Two of us. All right, we'll see you people tomorrow. What do you have tomorrow, sir? Chemistry, okay? Commerce. Anyone, just prepare yourself. Tomorrow, before we start our class, we'll do this. We review our assignment. So, if you like, come late. I'll review it. You lose that one. So come early. 4 p.m. we'll start. All right. See you. God bless you.